Big idea here is that when we talk about how concentrated something is, what do we mean? It's actually a word that we use outside of just a chemistry context. You've thought about if you buy, I don't know if maybe your family is like bougie and you buy like the orange juice that's expensive in the jugs. I buy the frozen orange juice, the concentrated. Anyone else buy the frozen orange juice? Yeah, right? It's cheaper. It's good. You can't beat it. But you don't just thaw it and drink it. Why not? Well, it's thaw. Yeah, you're not going to drink it frozen. Right? It's hard to drink a frozen thing. But you have to do more than just thaw it. You have to do more than just unfreeze it. Why? What do? It's a concentrate, which means what? Yeah, in fact, what have they done with the orange juice to before they freeze it? Do you know? When they put it in a can like that? Yeah. They condensed it, good, which means they've taken what out? Water. They've taken water out, right? So we say it's concentrated. It's got higher levels. I've got some styrofoam cups with lids that I'm going to grab for you in just 2 minutes. It's got more water, more stuff and less water in it, right? And we call that concentrated. If you go to drink that, it'd be sickly sweet and kind of horrifying tasting. And so you add water back into it. You mix it in, yeah. Exactly right. Yeah, we add water to them, right? And if you just drank the fountain syrup, it'd be awful, right? Like just truly, truly awful, right? Like really, really, really sugary and really sweet. Even if I do buy good orange juice, like the expensive orange juice, I mostly don't because I'm a cheapskate. I'm getting older and I find it a little too sweet. So I add a little bit of water. I like it a little less concentrated. We can control how strong something is. And that's probably the word you'd use more often, right? You talk about how strong something is. But the other word for that is how concentrated something is by controlling how much water is in it. It's pretty easy to add water to something, right? To make something less concentrated. It's a little harder to take water out, but we can do it. You can either do it by filtration or you can do it by evaporation, right? But you can get water out of something. So concentration is just a way of saying when we dissolve a thing in some other thing, when we make a solution, how much stuff is dissolved in how much solution. Does that make sense? So if we remember the words, the thing that's being dissolved, do you remember what we call that? The solute. Good. So usually it's how much solute there is per total volume, if it's a by volume concentration, or it can be how much total by mass. But usually concentration is usually expressed as some version of solute divided by total. And the other way I say that more simply is usually how much stuff is dissolved in how much volume. That's for a by volume concentration. This is the definition of it. How much stuff? Oh, excellent. All right. You can get back there too. Once you guys are all kind of decked out in PPE and stuff, let me know and I'll come get you started, okay? How much stuff dissolved in how much volume? Does that make sense? Now, you could measure this a lot of different ways. You could measure stuff in grams, right? You could measure stuff in milligrams, kilograms. You could measure it in pounds, right? If you are doing a recipe in your kitchen, you'd probably measure cups of water and you'd probably measure teaspoons of sugar or teaspoons of salt, right? But in chemistry, what unit are we typically going to use for how much stuff? Moles. Good. So most commonly, we're going to measure how much stuff in moles, and most commonly, how are we going to measure volume? Liters. Good. So the typical unit for concentration is how many moles of stuff we've dissolved in a liter of solution. And we give this title a name. We sometimes call this the molarity. And we shorten the unit so we don't have to write as a fraction as big M. Though I actually prefer to just say moles per liter. More often I will say moles per liter, but that is the same thing as saying molar. And we would say the concentration is some number of moles per liter, and that's the same number in what we call molar. Those two things mean the same thing. Do we have the extra handouts? Which one for Max? Oh, perfect. Excellent. There you go. Oh, you're really well. All right. So if we know that, then this math is actually trivial, completely trivial. I'm not going to give you a formula. If you want a formula, if you like a formula, it's really quite easy. We just say concentration is equal to the number of moles divided by the volume, right? But I don't like to think of this as, bless you. It's the number of moles of solute, the thing that you've dissolved, and the volume of the solution. But I prefer to think of it in that dimensional analysis sense, which is just, this is a fraction, right? And dimensional analysis, we work with fractions all the time. For the first time now, sometimes we'll actually start with a fraction in dimensional analysis. Now, we've always started where the first term so far has always been not a fraction. Well, now that we're dealing with concentration, sometimes we actually want our answer to be a fraction, so we'll start off with a fraction. So in this case, we're not even going to use the formula. We're just going to say we want to know the concentration of, in this case, what? Sodium hydroxide? Okay. So if we want to know the concentration of sodium hydroxide, we just say how much NaOH, right? How much stuff divided by how much volume, right? And you'll never bother writing that again, but we'll write it once. So how much sodium hydroxide do we have in this particular example? We have 2.48 moles. Okay, so we can put that in. 2.48 moles of sodium hydroxide. And what's the volume of the solution? Yeah, we're going to assume that dissolving that sodium hydroxide didn't change the volume. We'll say that we have a 3.42 liter solution. And now, just do the math. It's going to be a little bit more than 1. Or a little bit less than 1, rather. That's going to be like, I don't know. What is it? Great. And what sig fig land are we in? We have 3 sig figs, right? So 0.72 what? 0.725? Great. And then the unit, well, do any units cancel here? No. So the unit will be moles of NaOH per liter. Or, if we prefer, we can say 0.725 molar NaOH. And molar means moles per liter. So if you read this, you'd read this as moles per liter. I'll be right with you guys. And this would read as molar, which is the same thing as moles per liter. All right, now, the next one's a little bit trickier because you're going to have to do one-dimensional analysis step. But I want you to start with this same fraction and see if you can do it. We'll take it up in 5 minutes. But we're going to do the same thing. We want to know the concentration of sodium hydroxide. And we're going to start by saying how much NaOH. And we're going to divide that by the volume. Right? Only this time, how much NaOH is given to us as grams. And the volume is still given to us as liters. So that's good. But then you're going to have to do a conversion because we don't want grams per liter. What do we want? Moles per liter. Do we have to do anything with the bottom of that fraction? Nah, it's good. But we're not going to be happy with the top of it because we have to get rid of grams and we have to replace it with moles. I bet you can figure it out. Give it a try. All right? By the way, it'd be helpful to know, does anyone know how much a mole of sodium hydroxide weighs? Yeah, the molar mass of sodium hydroxide is 40.0 grams per mole, right? So if that's helpful to you at some point, there we go. Oh, right. Yeah, no, guys, everyone works together. Be a big team.
All have one result.
Yeah. If you want to do two, if you want to do two between you, three between you, whatever, go work together. So, we've got all the equipment we need to do. I'm going to go get, I've got styrofoam cups there, but I'm going to go grab some things I have in our lids. In just a second. You have two smokers here, which means you could, A, if you wanted to, you could use them for once. You don't have to. Just if you want to, they're here. Make sure you don't want to fish. This one is stepping right up. Going on green, this one here. Little. One that's blood. Things are fourth one. Up. Scale here, everything you got place, the solid sodium hydroxide here, be very careful with this. It's on your skin as you sweat. Sodium hydroxide on your hands. That solid here. Then as you once that's the time. Right, scale there. I made up 6.5 moles of sodium hydroxide. That should be plenty, obviously. You want to be pouring right at this. Yeah, but you'll want, you're not using oh, great. Okay. Oh, that's right, you are. And then if you need more 0.25, like, still use 7.5. Let me go get you a better styrofoam cup. You guys can get it. And the thing I'd say is, just keep in mind that you'll want to stir. The nice thing with this is stir like that. And then the temperature you want to feed it to the final is the highest temperature. At some point, it's going to come back. The highest value you get, that's what you want to call it. Yeah, so you want to know the starting temperature first. In the first one where you're mixing with chemicals, that's where we hope to have these sort of initial temperatures. It's actually going to be half of those temperatures, right? Does that make sense? Like in all the other ones, you have a little bit. In trial one, you're mixing solid. Second, solid initial temperatures. And if you still want to mix it to what you call the yeah, and then once you pick, once you pick, then go up and go up and go up and go up, then stay steady. Yeah. High enough. That makes sense. And you do any of these trials twice, you can make the trial 3 times if you want. Just make sure you keep track of it says you use 2 grams, right? But if you have 0.03, that's fine.
Somewhere upstairs. Yeah. All my pieces ish. I'm really staging my bottoms. And then I want to have those little slits in there. And you build together. And I think I felt better so far. And I'm like, but I can like it's me. So I'm like using my mom's motivation.
I left you for like 10 minutes and you put the thing on the stand. Salamander. Let's remember all the positives when you're woodworking.
Remember when you joined it so much?
Okay. What are we just punching each other?
That's like the only time I can make up. The rest you're like good at.
Sarah, I can do a lot of things for myself.
It's 0.08.
Like what? 0.8. It's 20.0 and it's grabbed from the it's not. Oh.
Ouch, it were both fine.
I don't remember the joint. And then wait.
Yeah, Sarah,
Or
remember when you messed up on your joint project?
Remember? That's on your joint project. Like that triangle thing. And then you made it like the
I
wrong
do.
I can't say it anything.
Peanut boy. At a baseball game, just hang up.
But mine was
Remember on the box when you made the bomb too small?
remember you're still doing the box.
Right with you guys. Somebody, if they think they got it, put it up on the board.
I want to do it. I want to do it. I want to do it, sir.
Remember when part of my fish did fall off?
Forgot about that.
I know what I'm doing, guys.
You both both our projects. Thank you. Where is it? Look at this bin now.
I think it's still in the room. You could use that as your second project, Sarah. I think it's still there.
You think I might end it in?
Oh shit, don't want to do that.
All right. Oh, Ruby. Wonderful. If you want to grab a lab coat and wear glasses, there's doing the calorimetry lab now, which is one of the assist to keep eyes on. Yes. No idea. But I mean, there's no open flames in this one anyway, so don't stress if you don't. But,
That's a 2 next to the 96, right?
Which one?
96 there.
Yeah.
yeah, friend, I'm getting low. I gotta go shopping. You are welcome.
Cheers, guys.
I know. And it's right on red. Oh,
How does he do that?
I'm sorry.
All right, shall we take a look at this? See how we
Oh.
did?
Mr. Orlando, how do you do that one thing?
What thing?
The circly thing.
I
the
found.
last one?
Oh God.
Yeah, you lasso.
Hold on. How do I cancel it?
Then you lift
Oh.
it, and
It's
then
like,
and you forgot the 3.
Hold on, guys.
so you guys think it's so easy. Oh, it must be nice to be able to just highlight your stuff and move it. And then here we are. And,
There you go. Look at that.
Yeah, keep that,
It's
Mr. Orlando.
still like off page.
Okay.
Oh.
What's off the page?
Look at
Oh my.
it.
Okay.
The numbers.
It doesn't need to be
the
that.
numbers that continue
Can we take a
off
look?
the page.
hey, oh, I see what you're doing.
Please excuse the interruption, but it's convenient for you. Can you go back to please come to guidance?
Yeah, you bet.
Would you go back? Thank you.
Great. Yeah, this is good. I'd like to see the unit here because we like to cancel. But that's great. The only thing I'd say is we could have done this in one step. Not one step, but one calculation. Not one step. It has to be 2 steps. But having said that, this is great. So this is good. Well done.
A little star.
Huzzah.
Huzzah.
All right. So this and a star. You know I can't draw stars. Why you got to do me like that? Okay, Max, hook me up. All right, hook me up. I need a star right there. All right.
What kind of star? Like those, like
I can't do
Oh,
it.
wait.
Okay,
Okay, just. Okay, I can rest my hand on this. It's not
Oh
going.
yeah, no, treat it like paper. Treat it like paper. Don't be shy.
Okay, there we go. That's a lot better.
Wow,
Okay.
that's beautiful. It's
Okay.
lovely. No, I like that. That's good.
you can't do that. It's so
Shut up. Whoa. People have tried to just, yes, but not right now. Right now I'm going to show. Right now I'll teach you, then you can teach me. It'll be a back and forth. It's good. But I'm an old dog, and it's hard to teach an old dog new tricks. I don't know if you've ever heard that.
Yes, it is.
Have you not? It's an expression. You can't teach an old dog new tricks. And
Are you a dog, Mr.
basically, I'm loyal. I'll eat just about anything. I like to sleep all day. Yeah, basically.
I sleep every night. I don't know what you're talking about.
But I do love to sleep. Like I love, like there's nothing if I have a restful day, I want to sit with a book on my couch, but I want to fall asleep at 5 pages into that book. That's my favorite thing. I love the feeling when you're trying to stay awake to read a book you're interested in, but you lose and you fall asleep. That's my platonic ideal. That's like my joyous spot. Sorry?
Don't you have work in the pages of the book when you're sleeping?
Yeah, I'd be terrified of that.
Well, like, I can't. I'd be like, am I going to sleep? I'm like,
Yeah.
I wake up often with like a book on my chest. Yeah.
Tell me what I did wrong.
Yeah, well, I think yes, but can we try doing it the way I would normally do it and see if that gels for you? And if not, then I'll show you. Is that fair? Okay, so this is great. This is a good solution. And I never want, it is so much better to get the answer doing it a way that makes sense to you than blindly doing it someone else's way. So this is excellent. Full kudos. Don't take this as a rebuke. What I would do is I would say, let's say that when we want to put how much stuff up top, right now we do know how much stuff, we just know it not in moles, but let's just put it up there anyway. Let's say we have 3.85 times 10 to 3 grams of sodium hydroxide, and that is in, what was the volume again? 4.12 liters? And then we can say, if I were to stop calculating now, I'd know the concentration, but I'd know it in grams per liter. And then I would say, okay, well, I don't want to talk about grams per liter. I like the per liter of it. So I'm going to leave liters alone. I'm not going to change anything about that. But what do I want to get rid of? Grams. Well, then where should I put that on the next fraction? On the bottom. And what do I want on the top of this fraction instead? Moles of sodium hydroxide. And wait a minute, I know what numbers to put in there. How much does a mole of sodium hydroxide weigh? 40 grams. Where's the 1 go? At the top with moles. And where's the 40.0 go? At the bottom. Now that's exactly what you did up above, but it's doing it in a single calculation. Does that make sense? And what units cancel here? Well, grams of sodium hydroxide cancel, leaving us with moles of sodium hydroxide on the top, and on the bottom we're left with, which is actually what we want. In this case, we don't want to cancel all our units, right? We want to have a unit on the top of the fraction, and we want to have a unit on the bottom, because we want our answer to be in moles per liter. In other words, moles divided by liters. And this will give you the exact same number, or it should, 23.3, which makes perfect sense, because 3,000 divided by 4 is roughly 1,000. 1,000 divided by 4 would be 250, but we're dividing by 40, so that's about 25. A little bit less, because this was not quite there, so it's a little bit less than 25, and that gives us 23.3. That number makes perfect sense to me.
So the only thing that cancels out is the grams that they use before.
That's exactly right.
Okay.
And that's moles of sodium hydroxide per liter. And you can see why they invented a new unit, because that gets clumsy to write. What's the other way we could write that? Very good. Oh yeah, I'm great. 23.3 molar. I'm just looking for attention. How am I doing? Sorry, I broke Max.
Thank you for saying this. Like,
Sorry. Yeah, what?
So while I was like doing it, I had like trouble with rounding. So I just want to clarify when it's like rounding something. For example, it's like 0.25. Will it be rounding to the 2 or what about 2?
When the next thing is a 5 and there's nothing after it, if it ends on 5 exactly, but you're rounding to here, then you favor the even number. So this would round to 0.2. But if it was 0.251, now it would round to 3. If there's anything after that 5. Did that answer your question? Did that clarify for you? Did that help you see where you...
see the answer at the top, so I thought the answer was the one there.
So you got this one.
Yeah, that's what I got.
Beautiful.
I see it up there, and I was
Awesome. You did great. Yeah, they actually did this. Conversely, they did this as a step 1, kind of a getting the table ready. And then they took that number and put it up here and did this as step 2, which is totally okay, by the way. So that was their final answer right here.
Yeah, I didn't see it up there, and then I like, oh my goodness. I heard you say 23.3, and I was like, what? And then I looked around. I saw it. Hold on. So you just put the 96 into the liters
That's, yep,
to get it?
that's right, yep. And so if you want to do it in 2 steps, by all means do it in 2 steps. If you prefer to do it in 1 step, do it in 1 step. Totally fine. I mean, it's still 2 steps, but if you want to do it in 2 calculations, do it in 2 calculations. If you want to do it in 1 calculation, do it in 1 calculation. Yeah. Yeah. Sorry? Oh, never mind. Oh, okay. All right, I won't. That was easy. Easiest question I ever answered. All right. Now, what if the units suck?
Oh. It says, what if the units are nuts?
Okay, well, what if the units are nuts? Well, they're crazy. It's still the same thing. The trick to me is still do the same thing. We want to do stuff over volume. Right? So even if the units aren't what we'd like, what's the stuff here? Iron sulfate. Cool. How much of it do we have? 7.2 milligrams. Okay, whatever. We have milligrams. All right, there we go. And what's the volume that we have here? 36.7 milliliters. Okay. That's annoying, but the first thing to say is we want to end up with moles per liter, right? But the first thing that's probably stressing out is the milli of it all, right? Milligrams, milliliters, right? Well, which one do you want to deal with first, the milligrams or the milliliters? Okay, so we don't want to talk about milligrams. So where would I put it? And that should be an iron 3 sulfate, which actually, let's take a second. Let's take a second and just figure out what this is. Fe, in this case, is taking what charge? 3 plus. So one of them would give away 3 electrons. 2 of them would give away 6. 3 of them would give away 9, yada, yada, yada. Sulfate is what? SO4. It takes charge of negative 2. So negative 2, negative 4, negative 6. What ends up being the magic number here? Yeah, Fe2, SO4, how many of them? 3. Okay, so that's perfect. That looks great. It's exactly, you can really tell. So we don't want to talk about milligrams of Fe2, SO4, 3. We want to talk about grams, right? And what's the conversion there? How many milligrams in a gram? Nope. 1,000. Always thousands. 1,000 milligrams, bless you, is a gram. By the way, if you ever don't know that, just ask. Okay? But now, we're not talking about milligrams anymore, and now we're talking at least about grams. And then we can actually do the same thing with milliliters, right? Only here, I don't want to talk about milliliters. Where am I going to put that? No. Because if I put it on the bottom, milliliters times milliliters would be milliliters Squared. I'm trying to get rid of something from the bottom. Where do I need to put it? On the top. What do I want to be on the bottom of this fraction? Not milliliters, liters. So where am I going to put that? On the bottom. What number makes this true? And as it happens in this particular question, those two things cancel each other out. Just happens to be the case. We're going to divide by 1,000, then we're going to times by 1,000. So there we go. So in this case, milligrams per milliliter is actually the same thing as grams per liter. So that's okay. We've done that. And now the last thing is, if I stopped calculating now, what would my units be? Well, on the top, what remains would be grams. And on the bottom, what remains would be? So it would be grams per liter. But we don't tend to measure concentration in grams per liter. We tend to measure it in. So what do I need to get rid of? And right now it's on the, so where do I need to put it? On the bottom. I appreciate your enthusiasm, crew. What do I want on the top? Moles per liter. Good. And now we'll have to take a moment and figure out the molar mass of iron 3 sulfate, which we can do here. What's the molar mass of iron 2 sulfate? Well, how many irons do we have? 2. Iron is what? 55.485, I think. 0.845, that's right. I should know that. And we have 2 of those. How many sulfurs do we have? 3 sulfurs. What does it weigh? 32.066. And how many oxygens do we have? 12 oxygens, right? Which is 15.9994. Don't really need that 4, but that's okay. 399.8. Everyone getting the same? So I don't need to do it. That's nice. How much?
399.9.
We should have a couple more decimals. 9, 8, 980.
The first one's supposed to be
880. 880? Okay. I mean, not that it matters. That's more sig figs than we need, but it is how many sig figs we get from that addition. So, might as well use it. So now we know that a mole of this stuff weighs 399.880 grams, and I can put that number in here, 399.88. Well, why would that be? Yeah, that's how many grams are in how many moles? 1 mole. Good. 399.88 grams in 1 mole. Yeah.
I know you said it'd be 1 mole, but wouldn't it be 3 because we calculated the mass for 3 SO4s?
Yep, but it's 1 mole of Fe2SO4
Oh.
You're right, that is the mass of 3 SO4s stuck to 2 Fe's. True. Which is 1 mole of Fe2SO4. How are they doing back there?
They're doing pretty good. Where can I get like a waste maker? There's only like this tiny box.
For now, grab a 1 liter flask. Don't use the beakers because it's acid. Let's use a flask. That way we can put a stopper on the top. But a big old 1 liter one. Yeah. Mm-hmm.
We stopped at 1 2 liters. Could we not continue to change that milligrams to moles and then?
You totally could have.
Okay.
Yeah, a great question. The question is, if you wanted to finish up with grams and turn it to moles before you did milliliters to liters, totally cool. The order in which you do it is what makes sense to you and your brain. So, yep, by all means. That's a great question. You could have even done these 2 conversions separately and then just put it in here as grams per liter. You could have done it like you did the first one and done 3 separate calculations and then come and put it into this fraction as moles per liter. Whatever, yeah, that's perfect. Is that a liter?
Yeah.
Yeah, that should be enough for you, right? Because they're doing like 100 mils at a time? Yeah, great. And can you just use the Sharpie and write waste on it? I have a Sharpie here for you. Good talk. Good talk. That was a good talk, right? Oh, thank you. Annie, you're a mensch. All right. And if we do this math, like a mensch, like a good one, That should be like 0.5. That would be 0.0005. That'll bring it back to 0.5. 0.5 divided by 4. It's going to be like 0.125, but it's divided by 400. So this should be like 1.25 times 10 to the negative 3-ish. What do we get?
4.90.
Oh, wow, I'm way off. Way off. Times 10 to the negative 3? Negative 4. Oh, yeah, I got way screwed up there. Oh, because not 100. It's 400. See that? That's 400, not 100. Okay, yeah, so what is it? 4 point something? 4 point... Yeah. Hi. No, I actually just made one, but thank you so much. 4.9. Except how many sig figs should we have? Right, like 2 sig figs. How many here? 3 sig figs. Good. How many here? Infinite. Yeah, because this is definitional, right? By definition, there's precisely exactly 1,000 grams or milligrams in precisely exactly 1 gram. Same with here, right? Infinite, 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 5, right? And so the result is 2 sig figs. So that'd be 4.9 or 5.0? 4.9 times 10 to the negative 4. There we are. And what's the unit? Well, everything canceled except on the top. Moles of iron sulfate per liter. And the way we'd usually write that is 4.9 times 10 to the negative 4 molar. That's the worst looking M in the history. That's not much better. That's going to have to be good enough.
It looks like an email. Like a letter.
Oh, you know, yeah.
It looks like the Gmail logo.
Yeah, kind of.
Actually, yeah, it's a really.
Yeah.
It's like an envelope. How's that feel? Not too bad? Reasonably okay? Yeah.
Can you explain more why you couldn't put 100 milliliters on the bottom? Like on the thing, the equation.
Sorry, can you say that again?
Like the 100 milliliters divided by 1 liter.
This here?
Yeah.
Why it's 1,000, not 100?
No, why you can't put it on the bottom?
Oh, sure. Because we're trying to convert a unit, right? So we're trying to cancel milliliters and replace it with liters. But we don't want liters to be on the top. We don't want it to be moles times liters. We want it to be moles per liter. So we want liters on the bottom. Does that make sense? Like the goal, or the unit we want at the end is we want to know how many moles per liter. So at the end, we want moles on the top, the numerator, and we want liters in the denominator on the bottom. So if we flip this fraction, liters wouldn't be where we want it. And if you did the math, milliliters is already on the bottom. If you put it on the bottom again, they wouldn't cancel, they'd multiply. And milliliters times milliliters would be milliliters squared. You'd start getting crazy units. Which, by the way, if the dimensional analysis makes you a little nervous while you're going, remember that I made that little dimensional analysis calculator in Teams, which is a little bit clumsy, but what I like about it is if you screw up your dimensional analysis, it will like scream at you because you'll get crazy units, like crazy units. So if we look here, I could just do we actually have a concentration question here. So I can make this into a fraction, just like we did here. And what did we start with? 7.2 milligrams of Fe2SO4 3. And it was how many mils? Or 36.7? Okay. So there we go. So our unit right now is, if we did this, we'd know we have 0.196 milligrams per milliliter. The -1 here means that that's at the bottom of the fraction. That's what a negative exponent means, right? So now if it does that sometimes. That was very frustrating. I'm just going to make it milligrams and forget the subscript for now, just because I'm trying to prove a point. Okay, so this would be 0.196 milligrams per milliliter. Then we said, okay, we don't want to talk about milligrams, we want to talk about grams. And we said the way to do that is that there's 1,000 milligrams in a mil. or in a gram, right? Okay. Now, if we tried to do the next one and say, okay, and next, I don't want milliliters, I want liters, and there's 1,000 mils in a liter. Well, if you look, what the math ends up being, this would be 2 grams times liters per milliliter squared, right? They don't cancel, right? Because milliliters here is on the bottom. Milliliters here is also on the bottom. That doesn't cancel, that squares, right? But if we switch it and we say there's 1,000 milliliters in 1 liter, now what we'd know is that there's 0.196 grams per liter, right? And then we said that 1 mole of this stuff weighed how much? 399.888. Or 880. And so we get 4.91, right? Want 2 sig figs, so 4.9 times 10 to the negative 4 grams. If I put grams down here, it will cancel, moles per liter. So again, this calculator is really clumsy, but to the best of my knowledge, it's the only calculator you can find on the internet that doesn't just calculate numbers, but also calculates units, even if it does it in a really half-assed kind of clumsy way. But it's better than nothing. That's what they're going to put on my tombstone. Joe Orlando. Better than nothing. Half-assed. Better than nothing.
Oh, I just scanned it there.
And it's going to be like a cheap, crappy looking tombstone, too. It's going to be like, they get this at like the discount store? Is there a discount store for tombstones? Is that a thing?
Probably.
There's got to be, right? They got to like crack in the factory sometimes and stuff, right? So surely like one, and where they like started writing somebody else's name, it cracked, so then they had to like cross hatch that out and put my name under it. What I'm saying is I want a discount tombstone when the time comes. I don't think I want a second hand. I feel a little weird about being the second person to be in an urn, you know? I don't think I could deal with that. Yeah.
They need more HCl, 0.25.
The 0.25? Yeah. Great. Yeah, I can help with that. Okay, team, ready?
Sure.
What if, and this, boy, isn't that a failure? That is 6.2 times 10 to the negative 3 grams. Okay, this is going to give us, I will be right there. I'll be right there. Though, honestly, all they need to do is use half 0.5 and fill it the rest of the way with water. Does that make sense?
Oh, okay.
So instead of putting, are they using 100 mils of that or 50 mils of that? However much they're supposed to, okay. However much they're supposed to use, do half that much with the 50 mole per liter, and then use distilled water to take it the rest of the way. And that'll be perfect. Okay. So, here's one of the great rules of dimensional analysis. When doing dimensional analysis, if your answer is a fraction, oh, I'm sorry.
Yeah, it's a little.
I'll change the other in a moment. If your answer is a fraction, start with a fraction. And I'll tell you what I mean by that in a moment. Like, for example, moles per liter, kilometers per hour, etc. Start with a fraction. The last few questions, we've started with a fraction, right? And the reason we started with a fraction is in each case our answer was going to be a solution, a concentration, and concentration's a fraction. Concentration is moles per liter, right? So if your final answer is going to be something divided by something, then you want to start your dimensional analysis with something divided by something. If your answer is not a fraction, did that make sense? Oh, you're not Ruby. But actually, I can still ask you. If your answer is not a fraction, don't start with a fraction. You can do it either way. This is the easiest way. If you just check that. So what's our answers going to be here? The question is asking us how much water. What's that going to be measured in? What unit? Liters. Okay, that's the answer. The answer to this question is going to be 5.2 liters or 0.085 liters or whatever. Does that make sense? Okay. Fraction or not a fraction? Liters. Not a fraction. So, we have two given things we could start with. We know this, which is the mass, right? And it's measured in grams. Is that a fraction or not a fraction? Not a fraction. Did that make sense?
Yeah, we just don't have enough 0.5 moles.
Oh, you don't have enough either? Great, give me 2 seconds. I'll come back and make you more. Don't even bother with that, then I'll make you just the 0.25. Give me just 2 seconds. So I didn't realize you'd be short. And this is the concentration, right? And that's measured in moles per liter, which is a fraction. So we have two numbers we could start with, 0.050 moles per liter or 6.2 times 10 to the negative 3 grams. Both will get you there. You can get to the answer with both. But to make your life easy, look at what you want your answer to be. What do we want our answer to be? Liters, which is not a fraction. So which one of these starting with will be easier? Grams, because it's not a fraction. Again, it doesn't actually matter. Both will get you there, but this will be easier. 6.2 times 10 to the negative 3 grams of sodium hydroxide. And we want to know how many liters of water. Well, that's no problem. But of course, we could just use the concentration to get us there. But the concentration is a fraction, which is good, because it could cancel and give us liters on the top and put moles on the bottom. We can just flip it, right? That's fine. But this isn't in moles, this is in... So we don't want to talk about grams. Where am I going to put it? On the bottom. And instead, we're always going to do chemistry in moles. This is one of the ones we always know. How many grams in a mole of sodium hydroxide? Yeah, there's 40.0 grams in 1 mole of sodium hydroxide. What units cancel? Grams. If I stopped calculating now, I would know how many moles of sodium hydroxide I have. Well, now I don't want moles. What do I want to know? My answer is going to be liters. But we can do that. Do we have a way to relate moles to liters? Yeah, because we know the concentration, right? We know that, what color did I use for that? Blue. We know that a liter of sodium hydroxide solution in this case contains how many moles? Yeah. 1 liter of our solution, right, contains 0.0500 moles of sodium hydroxide. Does that make sense? What units cancel now? Moles of sodium hydroxide. Which means when I've finished calculating, what's the only unit left here? Liters, and I'll know how many liters of solution I need. Does that make sense? Sure. Cool. I'm coming. All right, so guys, we need some 0.25.
Yeah. Oh, you thought an empire. No, I said volleyball practice. I did not say empire. No, I didn't say empire. I did not say empire. That's why you said let me know what it is. Because I was talking to you on the videos about it, so I thought like. Anyways, I thought you knew what I was on about when I texted you. Yeah, I know. I realize that now. It was like the last thing I talked about, and I like invited you. You know what I'm saying? Anyways, you want to come to volleyball practice today? Yes. Yes. You're gonna help me and Sarah get our reps. 5. What are you gonna do? Go home and sleep?
Are you serious? I did that. I quit. I would have taken my mom before she went out the door at 5 a.m. this morning, but I was working.
And then worst case scenario. What do you mean we'll see what happens? You just play in your games.
Oh, look out for the pen.
I found your little white thing.
This one's so wrong.
Which is what I would almost dropped shit. I need to be cute. Your girlfriend found your little white thing.
How long do you think we're gonna be? What time do you have to be home?
But it wouldn't it be cute, Sarah? We still get to hang out because Thea did that. Yeah. I'm pretty sure it was Thea and assistant or like I can't remember. She was like simplifying and you guys saw her. Yeah, and apparently some guy asked us to play out there, so the campers like the camp campers do like roll out together. Yeah. Because otherwise the dude have not our car.
I didn't even know that.
No, there was this guy at the camp as a camp counselor. Yeah, and
They were okay? They were fine? Great.
He's the only guy.
Okay, how are we doing? What did we get for a volume here? 6 times 10 to the negative 3 divided by 40 is going to be like, oh God, 1.5 times 10 to the negative 4. But then we're going to divide that by 0.5, which is like doubling it. So that should be like 3 times 10 to the negative 1.
3.1 times 10 to the
Negative 3. Oh, something like that. Negative 3. Oh, yeah. Okay. 3.1 times 10 to the negative 3? Yeah.
Is it necessary to write it like that? Like, I just wrote 0.0031.
Yeah, that's totally fine. realistically, if we're working with that kind of volume, what would we probably convert it to? We'd probably convert it to milliliters, wouldn't we? You don't have to, but if we did, how would you do that? Where would I put? What unit would I put on the bottom? What on top? How many mils in a liter? 1,000, right? So we just multiply that by 1,000, which would be 3.1, right? You don't have to do that, but like I didn't ask you to do that. But practically speaking, if I told you to go get 3.1 times 10 to the negative 3 liters, you'd be irritated with me, right? Versus 3.1 mils, you'd go get a pipette and get 3.1 mils. How's that feel? Okay? Solid? Okay? Yeah, it makes sense, right? How much stuff divided into how much volume. It does introduce to us a new wrinkle. Dimensional analysis with fractions, where you want the answer to be a fraction. You don't want the units on the bottom to cancel all the time. Up till now, we've only ever put a unit on the bottom of a fraction so that it will cancel out another unit, right? But now we're dealing with, for the first time, a case where we actually want to keep the unit on the top and the unit on the bottom. Maybe just change them. Does that make sense? So it's a bit of a stretch. We have a new kind of roadmap here, where we now know, if you know how many moles of something you have, so if we know how many moles of this thing A we have, we've always been able to figure out how many the mass of that thing, right? Where do we look if we want to know how many grams of something we have, given how many moles we have? Very good. We look at the periodic table, right? And not that we ever do it, but we know how to go to how many number of particles that is. Again, not that we're ever going to actually do that, because that's a big who cares. But what's the relationship there again? Yeah, very good. The 6.02 times 10 to the 23rd things in a mole of it, right? We did stoichiometry, where we said if you know how much A you have, you can figure out how much B you have. And then it can do its own thing as well. What do we look at to do that? If we want to go from moles of one thing to moles of something else in a reaction. Very good. Very good. But now we actually have a new kind of thing where we could figure out the concentration in moles per liter. And all we need to know to do that is we need to know the volume. Or we can figure out the volume in liters if we know the concentration, right? So our dimensional analysis map has kind of gotten a little messy.
You okay?
It's desperate for attention. Desperate for attention. It's my new ploy. Anytime I feel people's attention is waving, I'm just going to cough, and they'll be like, oh, is Orlando okay? I better pay attention to him. I have some cough drops. I will get one. There's some homework questions on here. You can also do concentration on the little app here, and you can choose to find concentration given moles, find concentration given mass, find moles given concentration, find mass given concentration, find volume given moles, find volume given mass. You can practice every kind of question. Does that make sense? And you can have it give you the formulas, or you can have it give you just the names. And if you want to make your life easier, it will show you the molecular weights so you don't have to bother calculating them. Does that make sense? So you can make your life as easy or as hard as you want. This, I wonder if this actually works. I think this was meant to set like the ranges. Okay, don't touch that, because all of a sudden we're getting negative volumes, and that doesn't seem right. I don't know. So these boxes down here, I think that's a work in progress, and my advice would be don't touch them. Oh no, I think I broke it. If you do touch them, I think you'll have to reload the whole thing. Yeah.
For the second one, when you said the average, did you mean like the temperature of just the acid and the temperature of the acid?
Well, that's not for the second one. That's the third one, right? Second one only has one liquid, right? So not till the third one you're combining two liquids.
Oh.
Yeah, in the third one, you'll have two liquids to take the temperature of. Any questions about that? Okay, make sure you get some practice on this. This isn't too complicated. Monday, we're going to do a little mini lab. No prep needed. You'll get a handout that you'll staple into your lab book. But Monday, we're going to do a little mini lab where we just practice making some solutions. I just say, I want you to, and we're going to use salt because salt's cheap. I'm just going to say, make me solutions at these different concentrations. And you can do it. And then I'll test them to see if you did it right. I'm going to do it like an analytical lab where you're going to be evaluated based on the accuracy of the solution you prepare. No questions. Yeah. Be a hands-on lab. This unit has a bunch of hands-on labs. You're going to learn some skills. Have you seen people do titrations before in a different class? You're going to learn how to titrate. So we're going to learn all kinds of fun lab techniques, which should be great. Yes, my friend. Well, so now if you think, okay, so you've turned mils into liters. So now, if we go to the roadmap I just made, you say, okay, I want to go from volume down to mass, right? Right? So how am I going to do that? Well, you're going to use the concentration to turn moles to liters into moles, right? Then, so in this case, you actually had an additional step, which is you had the volume in milliliters, right? So you're going from volume in milliliters to volume in liters to moles to grams. How do you go from liters to moles? You know the concentration, which tells you how many moles are in a liter. So your next fraction, you're going to say, I don't want to talk about liters. Where do I put it? I want to talk about, it goes on the top. And then what's the number for that? Beautiful. Does that make sense? Right? So our map can actually walk us right there. From volume in mils to volume in liters to moles to grams. Does that make sense? I know this diagram's kind of stupid, but it actually really always helps me because every one of these is a fraction, right? And again, if we're starting with a fraction, you'd only ever start with the fraction if you want to end with a fraction, right? Failing that, because you could have started with the fraction here, right? But then you're going to have to do some finagling. So that's the other law, which is since our answer is going to be grams, that's not a fraction. I'm going to start with the volume. I'm going to work my way to grams. Does that make sense? Cool. Are you sick? You poor thing. Sick or allergies?
Yeah.
Nana, and look, but you're here because you're tough. Tough as nails, twice as smart. Yes, my friend. I'd like them today. I thank you for mentioning. I'd like your lab notebooks today if you got them. But honestly, seeing as I forgot to mention it like 11 times, if you don't get to me till Monday, I'm not going to penalize you. And let's be honest, I got a stack of marking to do this weekend, which I think is literally about yay high. So if you take one thing out of it, maybe I should thank you. Like, buy you a nice.
So is my sign to like not hand in my lab?
Well, if you've done it, hand it in. But what I'm saying is if you need the day, take the day. You know what? I've needed a bit of grace these last couple weeks because I let the play get me way behind in my marking and I'm way not caught up. I do think, is there anyone here who still needs to write this test so I can hand that stupid thing back? You can see your grades for your test online already, but I will get that handed back to you once everybody's written. I've still got a couple holdouts. Yeah.
Okay, since I, for some reason, cannot grasp that liter and milliliter thing, if I use that before, does
But
that...
for sure. No, that's great. Yeah.
So would
If
that
that's yes, if that's easier for you, go nuts.
Because I didn't know if that's like different.
No. There's no right way or wrong way to do this. So if there's a way that makes sense to you, run with it.
Because I don't understand why I just can't.
No, that's fine.
like,
That's great. To me, I like putting it all in one place. Some people's brains prefer to compartmentalize. One isn't right, one isn't wrong. It's just two ways of doing things.
Yeah.
This mic gets hard.
It's a 0.0.
I wonder if I left it in the back of Calford's room. No, that's Catherine Calder's guitar.
He said the eye in the middle.
Mr. Longo, I have to say that I like looking at different ways to do the same math things.
Yeah, I mean, I try to only teach one. You know what I mean? Like I try not to overwhelm people by showing 5 things up here, but I try to teach different ways if people need different ways. Because it can be confusing. There's a counterpoint to that, which is sometimes if a teacher shows you 6 ways, it can be like, well, what do I do?
I felt bad in math last semester. I know there was, I don't remember what, but I remember Mr. Hubbard took like 7
Well,
ways.
factoring can be brutal for
I
that.
think it was
Yeah.
factoring.
Factoring can be brutal. Where in my mind, it's like show people one way, let them get really good at it, and then yeah.
Can I see what I got at the test?
Yeah, you bet. Yeah, I'm gonna turn this off so everyone's not seeing what you did on the test, and then get.
You're fine. I promise you'll do better than me. I know that for a fact.
Me too. Like, what do you?
Just one sec. Okay, I'm gonna gray the names out. One sec. One. Settle down. Settle down.
Are you calm?
Oh shoot, I don't have yours written in here yet. See me at lunch. I'll show you at lunch. Okay, sorry. I marked it at home last night. I didn't have my computer.
Do you have mine?
Yeah. Okay. Just back up. Back up. Back off. Okay. One sec.
You are gonna be fine. You're gonna be fine. You'll live, I promise.
All right. Now you can come take a look, Sarah.
Oh.
Sarah.
Look, Sarah.
Yeah.
I saw my work, but okay, we're curious about
Did you? Highest grade.
highest.
Yeah.
So Sunana, I beat Sunana.
They all round, but it's you got the high one.
And Sunana got the.
Wait, how did that work? Like 0.0.
Because I mark everything out of 10, but if something's out of 3, then if you get a 5 on it, it's a weird decimal, right? So it doesn't matter. I enter things, so they get entered without a decimal place. So you all got the same mark. You all got the same mark mathematically, but in terms of for bragging rights, you got the 1. You get the bragging rights. Makes no difference in your achievement, but all the difference up here. Now when you see Annie in the hall, you can be like,
And Sunana.
hey, number 2.
I'm Sunana. You're not safe. All those times.
Like, whoa, like physically?
Everything. Yes. Are you able to print out that?
Yeah, you bet.
Since I need to give it this period.